I'm going to leave this up for just a minute. If you need any of the materials for the talk, please go to GitHub, and you can grab whatever you want. My name is Michael Starks, and I feel very fortunate to be here. It's my very first Unite conference. Thank you. Anybody else here a first-timer? All right, quite a few. Excellent. So just to give you fair warning, this talk does not assume any knowledge of Unity. We're going to do things that are pretty basic with Unity, but it does assume that you know a little bit about C#, how to write scripts, and how to do a little bit of programming, just to give you fair warning what to expect. All right, very thankful to Sphero, the company I work for. They're the ones who sent me here. We make the little BB-8s that roll around on the floor, and you can control them with your phone. A lot of fun. It's the connected play environment. We use the digital app experience on the phone to control a physical robot that's moving around. Great company to work for. And here's just a little bit about me. I'm a senior software engineer. Any other software engineers out there? Excellent. This is the right crowd. My background is actually in physics. I had the pleasure of getting to work at the Relativistic Heavy Ion Collider in Brookhaven. And then for graduate school, I got to work at CERN on the large, well, not the Large Hadron Collider, on the Large Electron Positron Collider, which was this big experiment on the border of France and Switzerland before they replaced that tunnel with Large Hadron Collider, which has been used to discover the Higgs boson. So if you've heard about that, it's an amazing discovery, a great place to be. I also had the wonderful experience of helping to create the massive multiplayer online game LEGO Universe. Anybody like to play games here? Yeah, I'll be talking a little bit about games. Does anybody like to create games? Excellent. So we'll talk a little bit about that. In this talk, I'm going to actually go through, create a very simple game, and I'm going to tell you at the very beginning there are lots of things wrong with this game. Lots of room for improvement. It's just a place to get started. What I'm hoping is that you can use the code that I have there to develop it further into your own work if it's applicable to what you want to do. I've included my LinkedIn and Facebook links. I would have put Twitter down there, but I don't get on Twitter very much. So if you want to connect with me, please use Facebook or LinkedIn. All right, the name of my talk is Test Guided Development: How to Realize the Benefits of TDD with Unity, where TDD is test-driven development. There is a distinction that I want to make between the two. Test-driven development assumes that you're going to write a test for every line of code that you create. It puts testing first. And I think that that's a great way to develop a lot of software. It's a little problematic in the context of building a game with Unity. And we're going to see how that works. But that's the reason why I'm calling this test-guided development. All right, we have two pictures. The one on the left is called the testing pyramid. And this is an approach that has been put forth on how you should be testing your software. First, you write a foundation of unit tests, where you have a lot of tests that cover the very basic units, the building blocks of your app. On top of that, you have some component tests to test the interaction of those individual classes, methods, and units. And then on top of that, you have integration tests so that your systems come together the right way. And as you get toward the top of the pyramid, you have fewer and fewer tests. We have some API tests to make sure that you communicate with UI the way that you would like to. And finally, you have some UI automated tests at the top. And then manual testing is this little cloud above the pyramid, which allows you to do exploratory testing to try to find any edge cases that you may have missed by building these other tests. All of these tests within the pyramid are automated tests. You write software for the tests to be able to test the software that you're building. Unfortunately, this is not what I've seen at many of the companies that I've worked for. In fact, there's an anti-pattern called the ice cream cone, where you have lots of manual tests, maybe a few automated UI tests, and then not very many integrated tests, and definitely not enough unit tests. So for the software that you guys write, Do you feel like you're closer to the test pyramid? Or anyone? A few people? Or closer to the anti-pattern? OK. That is not a big surprise to me. It's OK, not a problem. What I hope to help you do in this talk is show you how you can do some testing with Unity, because ultimately, if you write a lot of tests, you're going to be able to improve the quality of the software that you write. If you have questions to ask during the talk, that's fine. I will also give you a time at the end so that you can ask a few questions after I'm done with the talk. All right. We have a list of topics here. I'll give a quick introduction to let you know what TDD is, and then we'll get on into some hands-on testing and development. We'll have some very, very simple examples. We're going to build out some game objects, talk a little bit about mocks and stubs, a few other more significant examples, and then I wrap up with a few hints on how you can get the most out of testing in Unity. I'm not an expert at testing. I mean, I've tested software for years and years and years, almost as long as I've been doing it, but a lot of that was manual testing and ad hoc testing. It was not until about 4 years ago that I ran into this book by Kent Beck called Test-Driven Development by Example. If you're very interested in this topic, I highly recommend that book. He's amazing in the approach that he demonstrates in that book to show you how you can test your software. And it's basically a great way to practice the skill of testing. Because just like writing any code, the more you do, the better you get at it. So the more tests that you write, and the more you get into this habit, the easier it becomes, and the more you can do. A lot of times we have legacy code, and Michael Feathers defines that as code without tests. A lot of times we write a big system, and if we don't write tests at the beginning, it can be very difficult to add tests later on. So what Michael Feathers has this book, Working Effectively with Legacy Code. The whole premise is, if you have untested code, you can wrap that and then start pulling it apart and adding unit tests to all the individual components that make it up. And he has some great patterns for how to do that. So these are the resources that I rely on when I try to figure out how to do a better job with testing. The idea of TDD is that you want to use tests to drive every single line of code that you write. And it's championed by the Agile community. I have a link here for the Agile Alliance. There are a few people who do not believe that's the best way to go about developing software. The guy who created Ruby on Rails has a blog that says, TDD is dead. Long live testing. So he's definitely in agreement that you need to have tests. He's just not convinced that you have to write them before you write the code that you're testing. So some different opinions there. Here's the basic cycle for how you do test-driven development. First, you write a test that fails. After you have that failing test, you write the code, the bare minimum code that you need to get that test to pass. Once the test passes, then you refactor your code, you refactor and try to remove duplication from your tests, and then you do it again. And you do the cycle over and over and over. And ideally, it happens fairly quickly. Write a test, or write a test, see it fail, see it pass after you update the code, refactor, and do it again. I would try to impersonate Darth Vader, but I don't think I'm very good at it. Just doesn't work. Anyway, why use TDD? The primary benefit from my point of view is that from the beginning, the app is written for testability. If you write the test at the very beginning, you know that you're going to be able to test this stuff without too much difficulty. Also, every important feature that you have is going to get a test. And so that way you'll know that if the test breaks, there's a reason for it. You can look at the code and see if you have a bug, or you can look at the test and see if it needs to be updated. But you'll know where you stand. Important conversations about the product happen early on. And this is significant because a lot of times you'll be given a general direction, build X. But what is that? As you explore, you get a better and better idea of what X actually is, what it is you're trying to create. And a lot of times, if you write the test first, you'll realize that you don't know enough information to write the code that you would like to write. And so you can get the information early in the process, which can speed up the project. Now, I'm not going to lie to you. It does take time to write tests, which means that there's a balancing act that you have to play. The more tests that you have, the longer it takes. And you slow down initially. The hope is that you speed up later in the process because it becomes easier to add new functionality without breaking existing functionality. So it's all about code quality. I have two stories that I would like to share. So the first story is from about 2 years ago. I worked at a company, not Sphero, that had issues with the code. It was an engineering application, a wonderful company, but basically the code was written in Visual Basic to begin with. It got ported into C#, and a lot of additions were made very, very quickly with no tests, and a lot of bugs got injected into the system. So it was a little bit difficult to work with this code base. What would happen is you would try to fix one bug, and you would end up making a new bug. So as soon as you try to fix something, you break something else, or you add new functionality, and you end up breaking a few things that you didn't even know that was the way it was supposed to work. Because as new people to the program, I was not one of the subject matter experts. I had a vague idea of how this was supposed to happen, but I didn't know all of the specifics. So because it was difficult to work in this code base, we started using Scrum and test-driven development. I basically championed Scrum, and one of my friends got us started on test-driven development. And that was the first time that I really got deeply into it. And it turns out that by taking the time to do that, we were able to get tests wrapped around a lot of the areas of this code base and make it much easier to work in the code base. So we slowed down initially, and then we're able to pick up some speed with new features or fixing individual bugs because we did not have to worry about breaking anything else. And if we did break something else, we would write a test around it so that it would never break again. So that's an example of where test-driven development worked very well for me. Another example is from a different project where there were a lot of tests written early on in the cycle, and then people started getting a little bit concerned because the deadline was approaching. So they cut a few corners, they went ahead and wrote fewer tests, and they had it set up where the test repo was separate from the project repo. So it was very easy to develop a lot of code without remembering to take a look at any of the tests. And by the time that we launched the product, it turns out that there was a large amount of tests that were no longer working. They had become outdated. And we don't know how good the code was because we didn't have tests on the new code. So if you're going to get into the habit of writing tests, you have to be careful to keep them up to date. It's a maintenance job, just like it is to write code. All right, it turns out that test-driven development is difficult with Unity. There are various reasons for this. I'm not going to talk about all of them right now, but I will talk about some. And basically, Unity provides a ton of functionality. And to me, after the talk this morning, it's amazing some of the things that Unity can do. So it's not our job to test the physics, the rendering, the UI, any of the stuff that Unity provides. We don't need to write tests for that. We need to write tests for the game logic code that we write. So Unity encourages UI-first development, and I strongly support that. Start with the UI. Start with how you're going to build your game, and when you get into a script where things are starting to get a little bit tricky, that's when you can shift over and start to think about what tests you're going to write to make sure that your code does what it's supposed to do. Mono-behavior objects are not easy to test. I'll talk a little bit more about that. And some objects require testing on a native device. So instead of test-driven development, I'm advocating for test-guided development. We're going to let tests guide our development effort. And again, it's important because of the quality issue. If we look at this picture from one of my favorite books, we see that a train came off of its tracks and landed somewhere in Paris. Not a good situation, especially for the engineers who worked on the project. So I'm guessing that they wanted to have a little bit more testing to prevent things like that from happening. Unity is amazing. And they provide the Unity test tools that work very, very well. And we're going to see how to set that up so that it works. The first step is to install the Unity test tools. I'm not going to do this because I'm going to mostly talk from slides. But every now and then, or if you have a question, I can shift over to Unity and show you how some of this works. So basically, once you find the Unity test tools in the App Store, you install them. And then you're going to be writing your tests inside the editor folder where you have your code. So in this slide, we see the Unity test project. And these are lots of sample tests that they've already written. One thing that's a little bit, you have to be careful with this is you see some failing tests. They provide those so that you have an example of what a failing test looks like. But when I'm going through test-driven development, I don't like seeing that much red. So I'll typically ignore those tests so that the Unity test samples are all green when I start working on my project. So the way that we write tests is by using NUnit. And this is what a test looks like. The first thing you do is you create a class that's going to be for a collection of tests. And you use the test fixture attribute at the top of that test class. And then you have a method that's going to be for a specific test. And at the top of that method, you put the test attribute. This test is kind of silly, but it's basically we want to make sure that the default values for some class make sense. So I say that the maze length should be 10, maze width should be 6, number of available rewards should be 3. Now, when I create a maze object, I can assert that the size in the x direction, the y direction, and the number of available rewards are all equal to what we want them to be. And as long as they are, those asserts will pass, the test will pass, and you'll know that the constructor is doing what you expect. Okay, we'll see more functionality as we continue. The idea for this talk is we're going to create a simple game using test-guided development. My idea for the game is we're going to have a maze that a player can navigate through, and we're going to have a few rewards, a few hazards, so that the player has to be careful. They can collect coins maybe, have to keep away from the enemies so they're not going to get their health depleted. And then we want to show the player's progress. And as far as more specific requirements, we'll get to that as we sort of dig into this. So my initial user stories. As a player, I begin the game with maximum health and 0 currency. We'll say that maximum health is 100 points. As a player, I can collect loot to increase my currency. And as a player, my health goes down when I get damage. OK, those are great stories, but those are not the stories that I'm going to be testing directly. And the reason is because a player is an object within Unity and has a lot more going on than just the part that I care about right now. What I care about at this point are the player stats. So I'm going to think about my tests in terms of a player stats class. So I can rephrase this and say that the player stats are initialized with maximum health, 0 currency. Currency in player stats can be increased or decreased, and the health in player stats can also be increased or decreased. So those are my initial to-do items. Let's see how this works to try to build this functionality into the game. So I begin by writing a test. You can ignore the Z that I have in these names. It's just a quirky naming convention. So we have a test fixture called player stats Z test. The first test that I'm going to write is this one called player begins with maximum health. We arrange that test by setting the max health equal to 100. And then we instantiate a player stats object. And we assert that the current health, after we create one of these, is equal to the maximum health. Easy enough to do. But when I run this test in the test runner, it fails, because I have not yet written the code to make it pass. So that's that cycle where we see a test fail, then we write the code to make it pass, and then we refactor, if that makes sense. So here's what this looks like. My player stats Z class has current health, and in the constructor I set that equal to 100. When I do that, my test passes. You notice that I also have a player stats Z behavior. This is something that I'll do fairly frequently, where I have a mono behavior object that I don't necessarily want to test, but then I have that contain an object that I do want to test. So I can pull stuff outside of the mono behavior object, and then I can do my tests on that object. Okay so far? Okay, I see a few nods. Here my next test is. Player begins with no currency. I say my initial currency is 0. I create a player stats. And then I assert that the current currency is equal to my initial currency. Now, I just wanted to point out with this slide that when I try to build the software at this point, I get a compile error. It does not even build because I don't have current currency. There's no such thing. So when you have compile errors, you have to fix those compile errors before you can get to your failing test, or you consider that to be your failing test. And then once the compile errors are fixed, you can move on, have the failing test, make sure it passes, and go from there. So I've added current currency now to my player stats, set it equal to 0 in the constructor, which I would not have to do because by default it would be 0 anyway. But having done that, my tests pass. Next up, we want to make sure that the health can be updated and that the currency can be updated. Again, when I first write the test, I get compile errors. I'm updating the health by -25 a couple of times, and then with currency, I'm increasing it by 25 a couple of times. So I'm thinking about this as having one method that can handle both increases and decreases to these values. Here's the class before I implement those two methods. This at least gets me to a point where it compiles. But then when I run the test, you see that those two tests fail. My next step is to make them pass. So I write the code required to make those tests pass. I say that current health is equal to what it was plus the delta health. And the same thing with current currency. And now, once I've implemented that, my tests pass. So we're starting to get into this rhythm of seeing it fail, pass, and then we refactor. So far, I haven't had much in the way of refactoring to do, but we'll get there. This is an example of where the tests were, this is actually very, very important. And I would absolutely say that the exceptional cases are what you should probably test first. In this case, I didn't think of it right away. So as soon as I thought of the exceptional case, I added a couple of more tests. In this case, the player health cannot exceed the maximum health. If I allow you to just keep adding points to your health, eventually you can have a health of 1,000, and we want you to have a max health of 100. So I'm adding that as a test that fails, and then I'm also going to say that the health cannot go negative. So we have a couple more tests, and you'll notice that 2 of these tests are indented. The reason for that is that I'm using test cases, which we'll see on the next slide. Instead of having the test attribute at the top, I can have a test case attribute, and I can pass in parameters, in this case delta health and expected health. And by doing that, I can have multiple tests that use the same code, basically, and I can test different conditions. Now in this case, it's sort of silly, because -120 and -150 both give you the same result. So there's no reason for me to have 2 test cases here. But it does give me a thought for how I can refactor this code. So that's what we'll talk about next. We want to remember to refactor. So once I get these tests to pass, I look at this, and I see that the code needed is that I increment my current health, but if it's greater than the maximum health, I set it equal to the maximum health, and I similarly have a bound like that for 0 health. Same idea with currency. I do not want the currency to go negative. For this game, I'm not going to let you go into debt. So that's the code to make the tests pass. And now, I'm going to think about how I can refactor the tests, because the way I have it right now, the tests for cannot exceed maximum health looks almost exactly like the test that I already had to make sure that you could update the health. So I'm going to refactor this and instead just have 2 tests. Player health can be updated. Player currency can be updated. And with these 2 tests, I now have 3 cases for each one. If I pass in 20, I expect the result to be 100, because I cannot exceed my maximum health. If I pass in a negative 20, I expect my health to go down to 80. If I pass in a negative 120, I know that my health cannot go below 0, so I would expect 0 to be what I get there. So I'm using test cases in order to write these tests. Same thing with currency, so I won't go into that in any more detail. Am I going too fast, too slow, or is this about right? Good? Okay. We will speed up a little bit as we get further along. Now we're in a position where we can complete the initial stories. We are in this rhythm where we fail, pass, refactor, and by doing that, we've completed our initial to-do list. The player stats are initialized. We have player stats that can be increased or decreased as far as the currency, the health. We know that we cannot exceed maximum health. We know that currency and health cannot go negative. We're in pretty good shape. But we did not satisfy the initial stories because right now, it's just one class that's managing the player stats. It has nothing to do with the actual player. So that's what we need to do next. We jump into Unity, and we set up a 3D scene that's going to allow us to have an actual player. In this case, I'm basing this on a tutorial that you're probably familiar with. It's the roll-a-ball tutorial. We basically create a ground plane, give it a material, create a sphere to represent the player, and then we use cubes to represent loot and hazards. This is what the scene looks like in Unity. And I'm not going to go over the details of this because, again, this is from a tutorial roll ball. You search for that, you'll find it very quickly, and you can see exactly how all of this works. Plus, all the code is on the GitHub link that I gave you at the beginning. I'll put that link up again at the end, so you can get all of this. You don't even need to take notes. The basic idea here is that you make sure you have a rigid body, and then during a fixed update, you accept input from the user, and then you create a thrust vector, add force to the rigid body, which is going to push that ball around so that it rolls. Again, this is all Unity functionality, which means we don't need tests for any of this stuff. Next, we update the player control to handle collisions. We have an on-trigger enter, and when we get that trigger, we're going to determine the collision results. I've used tags because that is what happened in the tutorial, where we have a reward object or a hazard object. And if we collide with one of those, if it's a reward, we let you collect that reward by turning off this game object. And then we update the currency. If you run into a hazard, I'm going to leave those cubes in the game world, but you will have your health decremented. OK, so that's what we have so far. We'll move a little bit quicker now. We're going to let the camera follow the player. This is how that works. We're going to add materials to the cubes and modify the player stats to update the UI. That part is actually kind of interesting. I have a player stats behavior so that I can have a text field for your health indicator and a text field for your currency indicator. This is how the player is going to know what their health and currency values are. So I set all that up, and then when I'm in the update health method of the mono behavior class, I update my player stats. So this is an example of how you can pull functionality out of a mono behavior and have that tested independently. So when I first run through the game, this is what the screen looks like. I start with 0 currency and 100 is my health. After I roll around for a little bit, I pick up the currency, so I now have 10 currency, but I ended up hitting that hazard a couple of times, so now my health is down to 80. Next step, I want to create a prefab for an individual cell within a maze, because our goal at the beginning was to create a maze that the player could navigate through. So this is the prefab that I came up with. We have the 2 items, currency that you can, or the loot that you can collect for currency, the hazard that will damage your health, and then the 4 walls to make up an individual cell. Once I have this, I can think of it as a stamp. It's a prefab, and so I can stamp out lots and lots of copies of this to create as many of these as I would like. So to set up the scene, I need to set up the north wall, south wall, east wall, west wall. That's what the prefab looks like. And then we set up our reward cube, our hazard cube. You'll notice that I have specified the tag reward and a tag for hazard. And then we have our maze creator behavior. I'm going to take in a maze cell, which is my prefab, and then I'm going to specify the number of cells in the north direction, the number of cells in the east direction. And on start, at least for now, I'm going to create objects at the various positions. I worked out all the numbers so they're convenient to give me lots of cells. May have to refactor this later, but for now, it works just fine. In the editor, you can see where I specify the number of cells north and the number of cells east. Having done that, I have lots of cells, and we have a maze, and we're done, right? It's perfect. Isn't that a fun game? Well, it's a start. I think we need to remove some walls. That leads us to the next step, where we can identify some more stories and determine how we're going to move forward. A lot of times with TDD, I'll go off in one direction and solve the problem a certain way, writing tests, and then I'll come back, throw that away, and start over. And when I do it again, I develop things a little bit differently. So you don't always get the exact same code when you're using this idea of letting tests guide your development. But as long as you are completing the stories that you signed up for, that's OK. As a player, I can reach each cell in the maze. That was the problem with what we saw in the last frame. Also, I never want to see the border walls missing, because then I could just leave the maze entirely all over the place, and that wouldn't be fun. Also, I want to be able to enter the maze. I want to be able to exit the maze. And this last one is the interesting one. As a player, I never see adjacent cells with only one adjacent wall missing. What I mean by that is if I look at the cells 1 and 4 in this picture, if I remove the east wall of cell 1, I'm still not going to be able to get to cell 4 unless I remove the west wall of cell 4. So adjacent cells have to have both walls removed in order for there to be a path for the player to go through. So I'm going to come up with a maze shaper class that handles this idea of identifying border cells and finding the adjacent cells in the maze. Now, what's cool about that is the only thing that I need to do that is the number of cells in the north direction, the number in the east direction, and then I have everything I need to be able to identify the border cells and find adjacent cells. So those are my next to-do items. And we'll start with the idea that a maze cannot have 4 walls. If I have a default maze cell, I'm going to say that that's not valid because it starts out with 4 walls. So my assert now is a little bit different than what we've seen previously. I assert is false, that the maze cell is valid. A valid maze cell does not have 4 walls. When you create a maze cell, you start with 4 walls, so it's going to be false that it starts out valid. In order to make it valid, I need to remove some walls, and that's what I do in this next test. Maze cell has valid number of walls. Well, I start with 4 walls, and then I knock down each one of the walls and put an assert after each one, so I verify that 0, 1, 2, or 3 walls is OK. 4 walls is bad. OK, those tests pass, so that's great. Then we get into the maze shaper class. On the left-hand side, the 4 methods that we see are not implemented. I just got them to compile. So I return false for every one of these. That makes this compile, but we do not pass any tests. But it does tell me what I need to do. In the constructor, I set the size north and the size east. And then I want to be able to check if we have a border cell for any given cell index. In my test, I create a shaper. And then I want to be able to pass in a cell index and a wall index and be able to ask, is that wall a border? Because if it's a border, I don't want to get rid of it. But if it's not a border, it's a good candidate for removal. So that's what my test looks like. And I only have one test case to begin with. But after a little consideration, I'll add more test cases. This is what the code looks like. I have some logic here to determine if the north border cell, if I have an east border cell, a south border cell, or a west border cell. And then I also added a method just to see if I have a border cell at all. And I run the tests. And initially, those first 2 failed. got those to pass, and then I said, hey, now that I have those passing, why don't I make more tests? I wanted to test the upper left-hand corner, the lower right-hand corner, cell in the middle, just to make sure that everything's behaving roughly the way that I expect it to behave. All of those pass now. Next, we want to let the maze creator use this shaper. So my maze creator has to be able to set the outer walls, and if we have a west border cell, then I'm going to let the maze cell at that individual location set its outer wall as a border. And once I establish that, then I can avoid knocking down the border walls while I can knock down all the other walls that I care about. And these are our tests. I have a shaper. I find the adjacent cell index by passing in a cell index and a wall index. And I say that that result should be equal to what I expect. And find adjacent cell index, I decided that that should return a -1 if there is no adjacent cell. So if you're at the top of the maze and you ask, what's the cell north of me? There is no cell north of you, so I get a -1 back. So I really quickly wrote all these test cases just to make sure that I had coverage. And when I ran these, after writing the code, it turns out that I had a lot of failures. This is an actual example where my test caught a bug after I'd written the code that I thought would make it pass. So that's good. By letting tests guide your development, you can oftentimes catch bugs that then never get into production. And what's cool about that is if you find a bug very late in a project, it's much more expensive to fix than if you find it early on, fix it, and it never gets into the code base to begin with. So we look at the code to see where I made my mistake, and you'll notice that I had to check, if it's not a border cell, don't do anything. Well, obviously that's a problem, because even a border cell can have walls that are not border walls. Does that make sense? So yeah, I need to check every single wall of interest. So once I rewrite the code to do that, all of my tests pass, and we can keep rolling. All right, a little bit of hookup was necessary to make sure my maze creator could use the shaper and that the walls and everything were connected the way they had to be. But once I do that, I can create a maze. I do have to admit that I cheated a little bit. With this maze, it is possible that it's not going to be a good maze. And what I mean by that is we define a good maze as being able to reach every single cell in the maze. And in this case, every cell is accessible. But it turns out that if I'd run this over and over and over again, eventually I can get a maze where there might be a wall up there at the top, another wall over here, and you have one half of the maze divided from the other half, and there's no way to get out of the maze. So I still need to put logic in to prevent that. But the way that I generated this was basically by, in most cases, removing 2 walls from every cell in the maze. There are many other algorithms that we could do, many other requirements that we could put on this to get different types of mazes. But the cool thing is that I can run this over and over again, and because I randomly am removing walls, every time it's going to look different. So that's cool. Any questions about that before we move on? All right. The next step is to just look at a few really quick examples, not related to our maze project, to show what you can and cannot do with tests. It turns out you are able to test monobehavior objects. And I say that it's OK, but it's not really OK. It's not easy. So I mean, in the first case, when I try to construct a simple behavior, if it's a monobehavior, I get a warning that says that's not how you're supposed to create monobehavior objects. It's certainly not the way that you do it when you're in Unity. But nevertheless, I can take that object, call handle collision, and as long as the handle collision method increments the collision count, I can check to see if my collision count is equal to what I expect it to be equal to. So that works. That's OK. But something you need to keep in mind is that the awake method is not being called. So if you have a lot of logic that you put into the awake or the start methods of your monobehavior, that logic is not going to be called when you're running it from the test framework. So you have to be careful about that. Same thing with serialized fields. That's great when you're working in the editor. It's not so good when you're running tests. So when you run tests, it's going to take a default value, but it's not going to allow me to set the collision count to anything that I want it to be. So when you have serialized fields, you have to be careful. And I would say in general, it's probably a good idea not to try to test monobehavior objects. It's better to pull the functionality out of the monobehavior into a separate class that's much easier to test. Sometimes it's difficult to test the actual code for all of the objects that you have. In those cases, a lot of times you're going to want to write mocks and stubs. Martin Fowler has a good article that talks about the difference between those. But basically what you need to know is that they are fake objects that are substituted for the real objects that are used when somebody actually runs through your game. So we're not going to play with the real objects. We're playing with these fake objects. And we can go through these steps to actually set things up. We write the minimum object interface that I need in order to create a mock or a stub. And the reason I do that is because of NSubstitute, which we'll see in the next slide. NSubstitute comes with the Unity test tools, and it's a great way to handle cases like this. So we use NSubstitute to substitute for the object once we've already created a small interface that that object can implement. And we'll see an example to see how that works. We then specify the behavior that we need for our test, and we complete the test. So here's an example. We have data manipulation tests. Specifically, I want a load data test. And this is all just made up, so don't worry too much about the details. But basically, I'm saying that there's a data count of 210, an expected group count of 3, and in order to have a data handler, I need to instantiate that with a data loader. But maybe I didn't write the data loader, or it's some complicated thing that I don't want to have to bring into a unit test. So what I do, instead of including the data loader in my test, is I substitute for the data loader. I create an interface, iDataLoader, and that allows me to create this variable data loader sub, and that becomes my substitute. I pass that in to the constructor of data handler, and that allows me to do a test on the data handler object. Now, the data loader sub has to return a result for the methods that are defined in the interface in order for it to behave in a way that's going to make sense for the test. So what I'm saying here is that when I call the method getDataCount on the data loader, I want it to return a value, in this case, the data count that I defined as 210. When I do that, I know what the expected group count should be, even without knowing what a group is. So I can assert that when I get the group count on the data handler, it's going to be equal to the expected group count, assuming that the data loader substitute is doing what we intend it to do. So in this case, the mocks and stubs are being used in the same way that the real objects would be used without the hassle of having to be able to create one of those real objects. So a very useful tool. NSubstitute comes with the test tools, so that's great. My one word of caution is you want to use mocks and stubs judiciously. It's a wonderful tool, but you don't want to run all over the place. It's better to use the actual objects when it makes sense. But there are definitely cases where you're not going to be able to do that, and this is very helpful in those cases. All right, that leads me to the hints section of the talk, where I give you a few ideas based on my experience. I've not been doing this that long. I'm sure there are other hints that people can give you. But let's get started with what can you do if it's difficult to write the test that you want? Sometimes tests are not easy to write. So my first question is, do you really need that test? If the answer is yes, then you can think creatively about how you can test what you really care about. In some cases, that means writing a system test if you have a good way of testing the system, although in Unity that can be a little bit tricky. In other cases, you can pull stuff apart a little bit and have a unit test that gets at the functionality that you most care about. And you've seen some of the approaches from earlier in the talk of how we can do this. The other advice I would give is go to the Michael Feathers book. His book, Refactoring Code, gives you lots of techniques that you can use to test code that's difficult to test. So if you have legacy code, you can wrap the functionality with system tests. In our case, it might be easier to use manual tests to make sure that the system, or one part of it, is behaving the way that we expect. And then we can extract a method or extract a class and get unit tests written around those methods and classes that we've extracted. Then all of that is tested really well, and it's not going to break in the future unless the tests tell you it's going to break. And then, as long as you make sure the overall functionality is still working the way that you intended it, you're in better shape than before you did this. So when can a test help, and when is it not helpful? Tests are great if you want to verify that important functionality does not change. That's one of the things that I like most about testing. Once the test is in place, if I'm running that test all the time, I know that that functionality is doing what it's supposed to be doing. Also, tests are a great way to document how the code is supposed to function. A lot of times people put comments in code, and after a few months of development, or you come back to it after a year, you have no idea what that comment meant, or the comment doesn't even correspond to what the code is actually doing now. With tests, as long as the test passes, it documents how the code is supposed to function. As we've seen, it prevents bugs, increases the quality of your code, and also it can help give you a direction of what to code next, how you want to put the code together. Unfortunately, it does take time to do testing, so it's not going to make you write code faster, although you may have a savings when you're in the maintenance mode and trying to fix bugs or add new functionality. And it certainly does not make you become a better problem solver. So it has a limited amount of good that it can provide. I think it's worth it, but it's not going to be a silver bullet to solve all of your problems. You want to be aware of all or nothing approaches. There are people who get, I would say, who are evangelists when it comes to the idea of test-driven development. You must write a test for every single line of code. In Unity, that doesn't work so well. You want to figure out what works best for you. And as far as how many tests to write or which tests to write, you're going to base that on experience. You're going to start practicing writing tests. You're going to figure out what the risks are, what are some of the riskiest areas where you definitely want to make sure the functionality is working the way you expect, and then you see how many additional tests you want to write to have confidence that you have the quality that you care about. A lot of times I get the question, is it bad to only have something public for a test? In order for a test to be able to access something in a class, it needs to be public. And maybe that doesn't make sense. In fact, I would argue that if you're making something public just for a test, you're probably doing it wrong. It's much better to refactor the code so that you have a class that has a public interface that you want to test, and you don't have to care about the private details of that class. If there's something that's very complicated within those private details, maybe you should have a separate class to handle some of that complicated logic. And then you can test the public interface of that class instead of the public interface, or in addition to the public interface of the first class. Another complaint that a lot of people have for test-driven development is that the design can be crap. How do you get a good design if you're doing this tight loop of writing a test, seeing it pass, or fail, pass, and then refactoring? And my answer is that you do it incrementally. How many people have worked with design patterns that they really like? Some good ones? Yeah. Design patterns are awesome. You do not want to throw that out when you start writing tests. Instead, you want to write the test incrementally, always refactor, and by refactoring, you can think ahead what would be a good design for this part of the system, and let that guide your development. The other important thing to state is that tests should interact with your object in the same way that the collaborators would. It's pretty obvious, but you don't write tests that are totally irrelevant to what you're actually doing in your project. I've already talked about bugs being expensive to fix when discovered late. Test-guided development helps you prevent bugs earlier on. This final hint is a really important one. Definitely keep your test code in a repository along with your source code so that it's easy to run your tests all the time. Before you do a check-in, run your test. Make sure everything's passing, then check the test code in along with your source code, and then your build server should actually run those tests as a matter of course so that you know that you have quality software. If you find a bug, write a failing test, and then write the code that's going to fix that bug, and you'll never have that bug again. We've already talked about avoiding testing Unity. Also, you do not want to develop backend functionality independently of the UI. We've talked about that. And the most important thing on this slide is that you never want to hesitate to refactor. That refactoring step is very important in order to remove duplication and give you a chance to improve your code as things change while still making sure the functionality is tested. If you're not familiar with solid principles, definitely take a look at that link. And those are very good ideas. And a lot of times you'll want to create a component level test before getting started if you're going to be pulling stuff apart. All right. Thank you for being here. I have to give a big thanks to Unity, not only for having this wonderful conference, but also for the rollball tutorial it was based on. The idea for the maze came from Cat-like coding. So these are all links that are really cool. And then, of course, I have to thank Sphero once again for having me come here. It's a wonderful experience. And I thank my family for the time that it took to put this together. All right, that brings us to our question and answer time. Let me know what questions you have.
So you talked about not testing physics or not testing modulators. What if you actually want to test that? Like in your example, you want to test that if you press down, or press down, actually going left and not going right. How do you handle that?
Yeah, that's a really good question. I'll repeat the question. What if you actually do want to test your input? If you press a button to move the character forward, that actually happens. My cheap answer is to say that you do a manual test. You just try it out, and does it work? But the more serious answer is you have to figure out what level of test will actually help you with that. For that specific case, I think that you could probably write a test that's not a UI automated test, but one that is just below that layer. And I'm going to be honest, it's not easy. It's going to be a little bit tricky to do that. But if that is too difficult, what I would recommend is use one of the UI automation tools to test. So I don't have a list of them right here, but if you look it up online, there are lots of UI automation tools, and some of them allow you to record a manual test and then play it back. And every time that you run that test, you make sure that you get the same result that you did previously. So that's one way that you could absolutely test that. Yeah? Yes, very good question. Basically, if you have designers that want to make sweeping changes to the project after you've gotten started, how can you ever get going with this? And my advice is that you set up the infrastructure to begin with. You download the Unity test tools, you get all of that set up, and then you write your tests initially where it makes sense. And then as the designers make sweeping changes, maybe some of those tests are no longer relevant. If a test is no longer relevant, you either update the test or you delete the test. And then you write a new test for the new functionality. And that way, as stuff changes, you try to keep up with it as best you can.
Oh, okay.
Does that answer the question?
Hello.
Okay.
Last question, I think, just over here in the corner.
Okay.
Could you explain briefly the different projects that are in your repo, what the differences between the three of them?
Yes, let me go to the repo. In fact, let me actually demo the project so you can see it live. I've generated a maze. I use the arrow keys to navigate through the maze. Whoops. I guess I don't want to go that way, so I'll come back through here. Definitely losing more health than I would like. Not getting as much treasure as I would like. It's actually kind of hard to move a rolling ball. But there we go. I got out of the maze. So the projects that I have here, we have three scenes. So basically, let me make this a little bit larger. In the scripts folder is where all of my scripts are. And if I just look at the root, I have game Z1, game Z2, game Z3. I would ignore the game Z1 and 2 scenes because those were scenes that I saved at a certain point on the way. The complete game is actually in game Z3. So game Z3 is the scene that you want to load in order to be able to play this. As far as other projects, let's take a look at how the code is laid out. I'll open the C# project. And we have assembly C# and then assembly C# editor. Inside the editor area, I have all of my tests inside an editor folder. And that's required when you use the Unity test tools. So these are all of my tests inside the editor folder. And then up here in the scripts folder is where I have all of the scripts that I'm actually trying to test. Did that answer the question? OK. Who else?
Okay.
To do what? The question is, can I run the unit tests on a device or just in the editor? Personally, I have used it in the editor a lot. I think it may be possible to test on device, but I have not done it. So I can't say for sure if that is possible. But if you're developing in the editor, I have this window right here that is the editor test window. I get to it from window, editor test runner. That's how I get to it. Pull up that window, and then here, I can run all of my tests. Because these are unit level tests, they run very quickly. And that's the other advantage of dealing with unit level tests. Because they run very quickly, you can run them as many times as you like, and it's not a lot of overhead. Other questions?
Actually, I'm sorry. I think we need to wrap it up now.
All right.
Thank you.
Thank you very much. It's been a pleasure talking to you.